Let's get today's lesson started by doing a little exercise where we're actually going to map the equation that you see written here with its graph and identify the slope and the y-intercept. Well, in each graph, we can tell what the slope and the y-intercept is because the slope is the number in front of x when it's written in y equals mx plus b form. So those are the slopes. And then the y-intercept are the numbers after the x variable that are written over here, the constants here. So there's a -1, a 2, and another -1. So these will tip us off as to what graph each one goes to. So the first one, we have a y-intercept of -1 and a slope of +2. Well, here's one that has a y-intercept of -1. Now, if I go up 2 and over 1, I notice that I'm right back on the graph. Up 2 over 1. So there's a graph that has a y-intercept of -1 and a slope of 2. So B matches up with number 1. Now the next one has a slope of -1 with a y-intercept of +2. So I notice that this graph has a slope or a y-intercept of +2. And if I go down 1 and over 1, I'm back on the graph. Down 1 and over 1 like that. So that's a slope of -1. So that particular problem matches up with number 2. So A matches up with number 2. And then by process of elimination, since 1 and 2 are both gone, we have 3 left. So C matches up with number 3. Now we're not going to let ourselves off that easy. Let's take a look. We have a y-intercept of -1. There it is. And a slope of down 2 and over 1. Sure enough, it does have a slope of down 2 and over 1. So that's why that one matches up with number 3. Okay, so today our goal is to write some linear equations in slope-intercept form, given that we have a word problem. So whenever we have a word problem, we have to take a look at some vocabulary. So linear word problem words that could help us out are words that would represent slope. So words or phrases like per minute, every day, each year, per month, or per hour. Some of those are phrases that represent slopes in linear equations. On the other hand, the y-intercept values that we could use are something like starting value, initial fee, membership fee, starting amount, and starting level. So this might sound really new to you, so let's do a few problems and just kind of show you how this works. Let's go to our first example. A water tank already has 55 gallons of water in it. That sounds kind of like an initial amount or a y-intercept to me. Then Tyler begins to fill up the tank. So it's going up. He's filling it up at 8 gallons per minute. So that sounds like a slope to me as well. So we're going to write a linear equation to model this situation. We're going to use x to represent minutes and y as the total amount of water in the tank. So if we write our equation, we have y equals 8 gallons per minute times x, which is the number of minutes. And then we already know that the initial amount that it had in the tank was 55 gallons. So we write down plus 55, and there is our first equation. What do you think? That was kind of easy, kind of different, but let's try another one. The window washer charges a flat fee of $25. So there's a flat fee. And then he also charges a fee of $3.75 per window. So write a linear equation to represent the cost y after he washes x windows. So let's write down y equals, and then the slope would be 3.75. 3.75, and that's a decimal. That's a little different than what we're used to seeing in our slopes. We're used to seeing a fraction, but this would really be 3.75 over 1 x, and then our initial fee, which would be the y-intercept on our equation, would be plus 25. So we're just basically using a little information and writing a linear equation to model that situation. So then the next question is, how much would it cost to wash 15 windows? Well, let's write that down and figure it out. So y equals 3.75 per window times 15 windows. And then all of that, we have to add the $25 on as well. Okay, so we need to get a calculator here. So let's grab us a calculator and multiply this out. So 3.75 times 15 equals plus 25. So on our first particular problem, it's going to cost us $81.25 if we get 15 windows washed. So that's a pretty good chunk of money, isn't it? All right, what about how many windows could we wash if it costs $70? Well, in this case, you're actually going to put the 70 where the y is, and you're going to solve this equation kind of like a two-step equation that we've seen in the past. So let's get it set up just like that. So now to solve it, we're going to grab our calculator again, and we're going to do 70. Now we're going to subtract off the initial fee of 25 bucks. And then we're going to divide by 3.75, which is how much it costs per window. And so then we are going to end up with x equals 12. So if we can get 12 windows washed for $70. All right, let's try another one. Boot camp at my gym charges a $20 membership fee and $2.50 for every time you go. So let's write a linear equation that represents the total fee y after x visits to the gym. So the total fee y is going to equal 2.50, how much it costs each time we go, and x is the visits to the gym. And then there's also a $20 membership fee. So we've got this standard $20 membership fee you have to pay before we even get started. Now, if you spend $67.50 at the gym, how many times did you go? This is another one of those like we saw on the last problem where we actually put $67.50 in the equation in the place of y, and we got 2.50x plus 20 for the rest of our equation. So let's go ahead and solve it. To solve it, we're going to subtract 20 from both sides. So we minus 20 from this side, and we end up with 2.50x. And then 67.50 minus 20 would end up being 47.50. And then we just have to divide that by 250. So we're going to use our calculator because that's a decimal and it'll take a little bit of extra time to do that. So 47.50 divided by 2.50 equals 19. So you can go to the gym 19 times for $47.50. So for $67.50 if you take into account that $20 membership fee. So how much would it cost to go 17 times? Well, in this case, we're going to write down the equation again, $2.50. But we're going to put in 17 for x instead of y because that's how many times we're going to the gym. And then we'll add 20 to our total. So we'll get our calculator, $2.50 times 17 visits, and that would equal $42.50 plus the 20. So we end up with a total cost of $62. Oh, let's double check that again. $62.50. That's to go to the gym for 17 sessions of boot camp. All right. So Henry's is a phone salesman. His base salary is $1,500, and he makes an additional $110 for every phone he sells. So let Y represent his total pay in dollars, and let X represent the number of phones he sells. So our equation, we're going to move down a little bit, give us a little room. So we're going to write Y equals, keep in mind he makes an additional 110 for each sale, so 110x. And his base salary just for working for the company is $1,500 a month, which will pay a couple of bills, but it's a good start. Okay, let's use this equation to find his total pay if he sells 24 phones. So total pay, Y, is equal to 110. Multiply that by 24. And then you add to that 1,500. So if he sells, if he's only working weekdays, if he sells one every day of the month, just about, this will be about how much he would make. So grabbing our calculator, let's do 110 times 24 plus 1,500. So if he sells 24 phones, that's not too bad. Let's go back to that number. That was $4,140. $4,140. Not too bad for selling phones, right? Especially if you like telling people about phones, that might be kind of a fun job. All right, so let's just see, how many more examples do we have? Okay, we've got 2 more examples here. So Laura is putting money into a savings account. She starts with $650 in the account, and each week she adds $70. So let's let Y represent the total money into her account, and let X represent the number of weeks Laura has been adding money. So Y equals, and she's putting $70 each week, so 70X plus $650. Okay, use this equation to find the total amount of money she has after 12 weeks. So that would just be 70 times 12 plus 650. All right, so let's get our calculator again. 70 times 12 plus 650 equals $1,490. So if she's disciplined and sells, or she saves her money like she's supposed to, she can add it up pretty quick and then, buy whatever she needs. All right, our last example. For babysitting, Nicole charges a flat fee of $3 plus $5 per hour. So let's write an equation in slope-intercept form. So Y equals, she's making $5 for each hour, and she charges $3 just to show up in case they forget and nobody's home. $3 to getting over to our neighbor's house. So how much money does she make if she babysits for 5 hours? Well, that's pretty straightforward. Y equals 5 times 5 plus 3. 5 times 5 is 25. 25 plus 3 is $28. So she makes $28 for babysitting for 5 hours. That might sound like a lot, but that's a lot of hard work to do for that long of babysitting someone else's kids. In any event, that's how you write slope-intercept equations from a word problem. So our assignment is either going to be a worksheet or on Alex, or one of each. So good luck.